Hey folks, so I just finished another job. This one was a lot of little tiny pieces, pretty flat, just a hair over 1/8 of an inch thick, and 500 of these little pieces. So I had never done a fixture plate before, but I figured that was the best way to go about it, was just make one big fixture plate that could hold as many of these things as close together as possible on my mill, so I can knock out as many of them as I can in one run. So this is what I came up with. So as you can see, I'm using the Mighty Bites, I forget what they call them, but these little, they're just eccentric little nuts and bolts. And they worked okay, so I guess to give you a gist of it, I had a ton of stuff. This is like 1/4 by 3/4 inch flat bar, it's just 661 aluminum. I'd cut this is about almost 15 inches, 14 3/4 inch strips of it. And then I'd clamp it down inside, and then I'd run it up against these little stops on each one. Mill one operation, then I'd flip it, bring it down here, and by then it would only be a 1/2 inch wide piece that I was finishing with, and so that would sit down in there and I'd clamp each one individually. You can actually see my little chamfers on here, each part that I made. So each one of these had its own part, and that was all good. So that setup worked okay. The biggest issue though was each one of those little nuts from the clamps would leave just a teeny tiny little mark on the part. And it wasn't a big deal, but it just was a couple minutes per part. And when you're doing 500 of them, that turns into a lot of time and work. Just to like a little bit of finishing time, 1000 grit sandpaper took most of it off, and it was all well and good. But for the future, I don't really want to do that. So I'm kind of thinking about going back to using tabs, and maybe not even really tabs, but maybe just leaving, I don't know, I'm going to experiment. Maybe 10 thou at the bottom, maybe get away with 8 thou or 6 thou at the bottom of the part. That way, when it comes off, you can just kind of break it out of there, peel off whatever material is left, maybe hit it really quick with the sander, and then have a nice part. So that's kind of what I'm going for. I'm hoping that'll work. This was cool. It was a learning experience. One little note, because I know someone will comment on it. I had my first experience with tool pullout, and you can see that sucker went all the way through. This is 3/4 inch aluminum to start with. And what made me stop the machine, because I couldn't see anything with the coolant on, was that it actually started bogging down the motor when it was making those adaptive passes. And so I actually stopped it just in time. I had a piece of just sacrificial aluminum underneath this when I was milling it, and it had already gone through the majority of that. It was about ready to kill my table. So I really lucked out on that one. I was like, oh my gosh, I just almost destroyed some stuff. And amazingly enough, that cut looks really nice on the inside. I was really impressed. But so tonight, I thought I would experiment a little bit and try some tabbies out. So I went ahead and cut this is 1/8 inch thick aluminum, of course, and a couple pieces of wood just so that I can drill a couple holes in here. Probably just use some wood screws because it's just what I got laying around just for a quick test. Clamp this to the table after I clean up all this mess and get this fixture plate out of here. And just try and mill out some rectangles in the contours, or with a contour path. That way, hopefully I can kind of see. So I've got in Fusion right now 3 different little rectangles. And then on the cam, I've got one that goes down and leaves 20 thou, one that leaves 10, and one that leaves 6 thou. And so I kind of want to see if pieces are going to go flying or what. That 6 thou one over here might get a little sporty. But I figure worst case, I lose an 1/8 inch end mill. I can live with that. They're only a few bucks a piece. And the one I'm using has been used for a very long time. So yeah, that's kind of what I'm thinking about doing tonight. Just kind of a little experiment. I really want to see if, number one, if the part will hold and at what thickness it'll hold. Number two, if I can get a decent surface finish around it. And then another kicker is a lot of these are getting chamfers on them. And if I just chamfer before I do this contour, that means the chamfer has to plunge into the material and it's doing a full width of cut pass, which I don't want to do. So in reality, I'd have to cut down and do a contour pass, bring in the chamfer, do the chamfer, and then do a finishing pass to really thin out that tab. So I'm going to try it on this one, just go as thin as I need to on here and then bring in the chamfer. And I want to see if the part gets all chattery with the chamfer as well, because that could save me a tool change if it does okay. And another nut I want to be looking at, surface finish around the outsides of it, making sure that that stays nice. So I do have a, right now it runs half the depth, and then it runs full depth. Then it does a finishing pass, like 5 thou finishing pass. So if the piece is being retained properly, the finishing pass should look pretty nice. Oh, and one more thing to note, I am fully aware that this is just a chunk of extruded aluminum and it is not perfectly flat. So when I say 6 thou on here, it very well could be 2 or 3 thou on here. I know that, and that's kind of why I'm doing a few of them. I just didn't want to take the time to try and get this mounted in a way that I could face it and do all that extra work. This is more of just a quick, let's see what we can learn type of thing, not some elaborate setup to get down to the nearest exact thousandth. My plan for that is once it breaks free, or maybe once it's done and doesn't break free, hopefully, right? I'll go ahead and just take my calipers and measure what's left of the material and see, how far it went down and go from there. So there you have it. Let's get it done. All right, so I went ahead and set everything up, cleaned off the table, looks a little bit better. Still got I don't know, it's not the prettiest thing in the world. I don't know if you can see that, but just like little markings and stuff. I cleaned it with some like Scotch-Brite and WD-40, and most of it cleaned up pretty nice, but it seems like the table, every time you use it, it just looks a little bit worse. Anyway, let's go back to this. Got a piece of wood clamped down. My screws were too long for this board. That's why I had 2 of them stacked together earlier. And then it occurred to me, just put the screws so that they're in the T-slots and you won't have that problem. So I screwed the aluminum down, very loosely tolerance-wise, dialed in my 0. I did make sure to do Z0 with the Heimer, so it should be pretty good. But as far as touching off on the corners, I'm only making 1/2-inch little pieces, so a 2-inch wide piece, tolerances shouldn't really matter. I'm not flipping apart or anything crazy like that. Yeah. Oh yeah, I did want to mention, this wood is pretty soft wood, so it does have some flex in it, and even this aluminum right now has a little bit of flex in it. So I hate to say, hey, check out my experiment, and by the way, it's not a very good experiment, but my setup may become an issue, I guess is what I'm getting at. In real life, if I want to make small little pieces, I may need a screw, almost at least every other piece, or every 3 pieces, something like that. This big, 7-inch span or so that I've got going on may just be way too much. But anyway, let's try it out. I got my 1/8-inch end mill in there ready to go. Yeah, we'll see what happens. My GoPro is still not playing nice with the coolant. I haven't come up with a nice solution for that quite yet. So sorry, you're not going to be able to see a lot, but I'll keep you updated right after the machine stops. All right, just completed the first contour. So this one was leaving 20 thou behind. I'm not sure how much of that you can see, but from what I can tell so far on the mill at least, looks like it's got a good finish. Didn't hear any chatter. It's good to go. I'm gonna go ahead and hit the next one. So the next one's gonna only leave 10 thou. It'll be right beside it. All right, folks, so the remaining 2 were drama-free. So let's take a look. I haven't even pulled the curtain back yet. Guess I should get some air on it. Okay, good enough. All right, so from a distance, they all look pretty good. When I try to grab onto this and move it, I'm getting drift on. Yeah, they all seem really solid in there. I push on this, but the whole piece moves. So I think, you can kind of see the coolant splashing up from the side right here. It tells me that the whole plate's moving, but I think that's just a poor test setup in general. As far as these pieces being separate from their they're, you know, stock. I think they're pretty solid. So now comes the next test. Oh, well, before I move on to that, I will say that I didn't notice any chatter whatsoever with this one. And then on these two, it was kind of about the same, which I guess really we only went down another 4 thou on this one. I noticed on the cleanup pass around here, I kind of heard a little bit of chatter, just a little high-pitched buzz going around. So I think these two were chattering a hair. This one was not. Once again, this is a 20 thousandths left, 10 thousandths, and 6 thousandths. So I'm gonna go ahead and try the chamfer. I don't think the chamfer is gonna do anything to those. I mean, they're pretty in there, which that's cool because that saves a tool change. If I wanna run a chamfer, I don't have to cut a bunch out of here, run the chamfer, then put it back in and finish the contour. So that's pretty cool. Yeah, we'll do that, and then we'll rip this off of here and see how hard they are to get out of the material and see what they leave behind as far as marks on the parts. All right, folks, so it is done. Let's check it out. So I will admit that I heard some whistling, I guess I'd say. Didn't really sound like chatter. Maybe it's just because it's a chamfer bit, so they're so small that they don't really chatter, but a little bit of a whistle on this last one. Other than that, though, the other two went perfect. They all look good from here, so I'll go ahead and unscrew this and we can try and pop them out of here and see how easy they come out and that sort of thing. All right, folks, so it is off the mill. Here it is. Let me get a nice close-up for you. So yeah, they really did, as far as surface finish and everything, turn out pretty nice. As far as the back, so that's where the 20 thou one was. You can't even see any type of dimples or anything. There we go. If I block the light a little bit, you might be able to see it. The one with 10 thou goes right around here. You can kind of feel it here. And this is the one with 6 to go. You can really see that shape there. So I'm gonna just try and kind of push the 6 to go out. See, even it, oh, got flex. So I'm whining right now about having to like sand these things and everything. But if I have to, oh, there it goes. Gotta be careful not to cut yourself. If it's this much work to get them out of here, then that might not be the best solution either, you know? All right, this is pretty cool though. With 6 thou, there's just a little tiny burr on it. That's pretty cool. So yeah, that's the 6 thou one. That's pretty darn clean. It looks like there's a little bit of tool mark right there on that side. If you can see it, there you go, in the light. But other than that, that's pretty clean. I mean, if I just take my deburring tool, here we go, let's just kind of deburr this a little bit. I don't know how to use tools. Do you guys go away from yourself or towards yourself with this tool? Or is it just whatever feels good? I feel like if I go towards myself, it just binds up and puts a big old ding in the part. Another thing is, how do you get around corners? Or I mean, curves, I should say. That's pretty good to me. A little bit of work to get it out. Just off of the amount of work it took to get this one out tells me that I'm probably not going to want to leave much more material. Let me find like a screwdriver or something to bust these other ones out with. Maybe just like a utility knife would cut the aluminum. We can try that. Oh yeah. So with 10 thou, you can really just dig in there with the box cutter, or there's probably something more sophisticated than this. See, it's still not fun. So 10 thou is like not fun. Okay, we got 2 sides done. Now we're getting some flex, and there it goes. I guess I'm quoting all these numbers, and I haven't actually mic'd any of this. I say mic'd, but I actually don't have a micrometer. I've got the cheapy Harbor Freight calipers. Let's see, this was a pretty nice smooth lip that came off of here. I'm gonna grab my calipers. All right, so if this is around 10, we can kind of believe what we did tonight. Ooh, 22. Oh, but it's totally warped and bent there. Hold on. This one's saying 7 thou. So at 7 thou, it's actually quite a bit of material there. I wonder if that's accurate. Because if that's seriously like 7 thou, then the other one must be, well, it would be most likely minus 3 thou. Yeah, I'm getting 6.5 thou right here. 6.5. So I mean the other one was only a few thou. This is about 3 thou under what I told it, which means that this other one was 6 minus 3 should only be about 3 thou. So something like this, you definitely would want to, I think, go to like a grinder, or not a grinder, but like a sander. It's a pretty hefty lip right there at 7 thou. I don't think I'd want to have to deal with that on every one. But at the same time, when it makes a better part, it makes a better part. Like you can actually bend it back. I want to see if I can just break it off. See what the edge looks like if you break it. Would have wanted to do this order like this or the other way. I mean, it's kind of one of those things where quality trumps time. If I can do this without having inconsistencies with the look of the part and that sort of thing, it's worth doing to me. But it's also one of those things where if I'm gonna spend hours and hours out here doing it, then the customer's not really gonna like the price much either. So I do notice that this one has a tool mark in the exact same spot as the last one. So I think that's just where the contour came in. It's like right there. I should bust out my sander because I bet the sander would just eat this stuff up. But at the same time, if you bust out a sander just to get this off, then you might as well not even bother. The other way of doing it, I was sanding the one spot down anyway, so if you already have a sander out, you might as well just do it the other way. But yeah, even at, this was considered 7 thou on my micrometer, multimeter, wow. So even at 7 thou, that's like, it's tough to get off. And now I've already dinged up the side of the part a little bit here and there just with my pliers, just ripping at it and stuff. Yeah, it's not as pretty as the other one. Yeah, I don't think I'm even gonna try and get this one out of here. This one with the 20 thou, it's on here. I think we learned 20 thou is too much. I think what it's gonna come down to is that this one that theoretically was only 3 thou left on it, it came out the best. And so if you can save that step, that final contour till the very end, then you don't have to worry about chatter with all your other tools and everything else. You can just run it and have a nice part come off of it. If you have to, minimize tool changes and you want to add some insurance to it, you can run a little thicker. This one came mic'd in at 7, but it was a lot more work to get off to get all the junk off of it. The other thing is if you put it on a sander and just had a slight angle on it, then you wouldn't mess up your machine side. So that might be a way around that too. This definitely makes me rethink using tabs. When I first started out, I've actually got a video of making, here it is, my pile of old parts and stuff and cool stuff I made and duds and leftovers and whatnot. Made this little guy. There's a video out making it on my Sieg. And so at that time I used tabs for everything because that's all I really knew how to do. So you can see that tab right here. That sucker's like probably 100 thou thick. That thing's huge. And that's how I've always thought of tabs, is this big chunk, and just spread out, 2 or 3. There's another one of them. I think I had maybe 4. 1, 2, 3, 4. And the fact that I can look at a part and go, oh yeah, tab, 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 that's a problem, right? That means I didn't do a very good job. And the tabs leave little whisker marks, little whisper marks from where the end mill on the contour has to come up and go around it and go back down. So I just really wasn't that happy with using tabs. And then I started watching more videos just recently because I'm not super happy with using the little Mighty Bite fixture clamps. And started seeing people using the same concept as tabs, but instead of having, you know, not very big ones, but they're taller, they're just leaving a lot of material underneath. So it's really flat and really like most of the part. And I think that might be a good solution for what I'm trying to do with lots of little parts, filling up this entire table with parts. That way the whole thing can run, make 70 or 100 parts at once, come back, rerun it with the next set. So yeah, that's where I'm at. It was kind of a fun little experiment, to be honest. It wasn't perfect. If I really wanted scientific results, I wouldn't have used a chunk of old scrap wood, and I would have definitely squared up the stock before I started. So don't criticize me too much in the comments, but this was just a quick one night little just try and learn something experiment. So hope you gained something from it. See you next time.